All right, kiddos. What rule is the only legal way of going?
Quotient rule.
Quotient rule. On quotient rule, we have to think about a what?
Bottom and derivative of the top.
A bottom and a top. So while I am orienting the board, that keeps on getting really confused and messed up. You guys tell me the quotient rule in general. Derivative of a quotient is?
Bottom d top.
Bottom d top. Minus top d bottom.
Bottom squared.
All over bottom squared. Now what does that, in context, mean? When we say bottom, what do we mean?
The denominator.
The denominator and keep it the
Same.
When we say d top, we're not just Jamaican, we're saying what?
Derivative of the numerator.
Derivative of the numerator. Minus top, keep it the same. D bottom means take the derivative of the denominator. 2x minus y0. Derivative of any constant is all over bottom squared. Yeah? Bottom d top minus top d bottom all over bottom squared. How many of you guys got that far? Nice. How many of you guys kept simplifying? Okay, because you should. How? Distribute, right? 4x squared minus 20 minus 8x squared plus 2x. Why on earth do I still have these parentheses?
So we distribute the negative.
I need to distribute that negative, right? And when I distribute that negative, I end up with 4x squared minus 20 minus 8x squared minus 2x all over. Has anybody, whether today or yesterday or in their homework, ever gotten so wrapped up with the top they forget to write the bottom? Ooh, there's 1, there's 2, there's 3, there's 4. It might happen to the rest of you. Keep writing it. What happens on top? We simplify stuff, right? Getting something like negative 4x squared minus 2x minus 20. What is one other way that we could keep simplifying?
Simplify together. Or take out a 2.
Well, the bottom, we could FOIL, but don't we kind of want it factored to see if we can reduce anyway? So we're going to always leave him the way he is and only mess with him if, after we factor the top, something matches. But is anything on top going to match that? We could pull out a negative 2 from stuff and we could try to factor, but it's not going to match x squared minus 5. So we could try to keep going. If you did keep going, that's totally fine as long as you did it legally and didn't mess anything up. You could have pulled out a negative 2. But stick it to the man. We have an appropriate answer. Let's stop. Why appropriate? We multiplied stuff. We combined like terms and we're like, forget it. Let's stop. Okay. Quotient rule. How are we doing? Kind of understanding. Are there still lots of places where mistakes can be made? Yeah. But how are we going to view mistakes? As stepping stones to learning, figuring out our weaknesses so that we can, get better at them and grow, right? Okay, let's keep going. Oh, this is in our composition book. Why? Because homework isn't technically 2.3 due today. Hold on, but what homework do we still have to go over? 2.2b. Okay, we'll get there. Keep your spirals close, but let's go ahead. We're talking about quotient rule. Let's finish this section. If you guys were working on 2.3 homework last night, which if you got discouraged with 2.2b, I would tell you to go to 2.3. Remember 2.2b is application-y stuff? The book I had last year, and well, basically all the years before that, would always say, let's learn derivatives, learn derivatives, learn derivatives. And then it would say, whew, one whole chapter of applications. Let's just go word problem after word problem after word problem. It was rough. What does your book do that's different? Basic rules, little application with velocity and rate of change, average rate of change. Product quotient rules, little application with acceleration. And it goes back and forth, which isn't necessarily super fun, but at the same time, you do get to kind of relax a little bit and just practice rules. then focus in and have a little bit of pain trying to look at applications. But we get to go back and forth, so that saves you from necessarily needing an entire chapter of all the different word problems you can ever see in calculus. Which hopefully will be nice not to have that. Huh? Depending on how far you got on homework, you might have dealt with some of these already and had to kind of think through it already. But we're going to deal with them together as well. One application, which is really just more rules, so this one's not going to be too bad. One application is, hey, once we learn the product and the quotient rules, we can learn more trig rules. And everybody says, yay, right? Just kidding. But, don't we already know 2 trig rules? What's the derivative of, review from your forever card, sine? Cosine. Positive cosine, yeah? What's the derivative of cosine?
Negative sine.
Negative sine of x. Don't forget your arguments. How on earth, without me giving you much of anything, could I expect you to be able to find the derivative of tangent without learning anything new? Tangent is sine over cosine. Oh my goodness, that's a quotient. Why did I still write d dx? What have I not done yet? I didn't derive anything like a limit. I didn't do it yet, so I have to keep that d dx to be like, hey, you gotta take the derivative. Derivative of who or what? Of my quotient, yeah? But I keep the d dx because that means take the derivative, and I haven't done it yet. I've just rewritten. True?
Yeah.
But now it's time to take the derivative, and how do I take the derivative of a quotient rule? Bottom. D top, derivative of sine. Cosine. Minus top. D bottom.
Negative sine.
Negative sine. All over bottom squared. All over bottom squared. However, we need to kind of simplify. It's not going to be quite as nice as polynomial simplification where we just distribute stuff. We got to somehow put things together, but let's start with the denominator, okay? Is there another way of writing the whole quantity cosine squared? Put the squared right next to the x. No. Because how do you know if that's the cosine squared or the x squared? You don't. Do I put the little squared next to the x to mean cosine squared, cosine, cosine? No. Where do I put it?
After cosine.
Don't get tricked by the trig notation. We write it with a little square next to the cosine to say, hey, cosine x times cosine x. Cosine is what's being squared. So these are the exact same thing, right? More proper notation and, I don't know, the in-between step. So how can I rewrite the top? Nice. Cosine squared of x plus y minus, and negative times a positive is a negative, plus sine squared of x. Oh, that's a disgusting derivative. Ugh.
Isn't that 1?
Cosine squared plus sine squared is?
1.
Oh my goodness, it's nicer than I thought. Oh my goodness, 1 over cosine squared is the exact same thing as? Who's the derivative of tangent? Secant squared of x. Why? Because secant is 1 over cosine. Since cosine is being squared, so is secant. Carla.
Why couldn't you just cancel out the cosine?
Remember? Up top, we have 2 different terms, and both terms have this shared denominator. Yeah. And we can't cross them off with one without shortcutting the other. Right? So then we say cosine squared plus sine squared is 1. 1 over cosine squared is secant squared. This was fun and all. Probably not. This was fun and all. But can't we maybe just memorize this from here on out?
Yeah.
Tangent's kind of important, like sine and cosine is kind of important, so I think his derivative is kind of important. I want you guys, ready, set, go, do the same thing with cotangent. But who is cotangent of x?
Cosine
Cosine
of sine.
divided by.
Good, cosine x divided by sine of x, quotient rule, go. I'm gonna zoom in just a second, but you guys, see how far you can get first. Bless you.
Oh, bless you, Kyle.
You guys don't need to watch me, you do it your way. Hopefully, which is the proper way. Bottom d top minus top d bottom all over bottom squared. Did you at least get the first step right? Bottom, keep the sign. D top, negative sine of x. Minus top, keep the cosine. D bottom, cosine of x. So then a positive times a negative, the first one's negative sine squared, minus, well, two positives, cosine squared. Oh man, you can't simplify this one. Take out a negative 1. If you take out a negative 1, you have a sine squared. Take out negative from both of them, plus a cosine squared. Oh my goodness. What's sine squared plus cosine squared? 1. And a 1 times a negative 1 is a negative 1. Well, that's better. And if we see sine squared in the denominator, 1 over sine squared is the same thing as cosecant squared, and there's a negative. Hey, I think there's a pattern with the trig functions derivatives of tangents. Tangent and cotangent. Tangent and cotangent, they both have a tangent in their name, right? Tangent and cotangent, they both have a tangent in their name. Their derivatives are super similar. Tangent goes with the square root of secant. Cotangent's derivative is negative cosecant squared. And if you remember possibly an old Pythagorean property from last year, tangent and secant was related back then also. And cotangent and cosecant was related back then also. But we have to memorize the whole squared thing, and oh man, he's a negative and he's a positive. There's no way to remember. Hold on. What happened before when we took the derivative of a C1? What sign did we get?
Negative.
And then we take the derivative of a C1, what do we get? Oh, and the non-C positive and the non-C positive. Hey, that's a trick. C, there should be a negative. Anyway, keep going. How do we do this one? Who is cosecant?
1 over sine.
It's a quotient. The only proper way at this point, from what we know, to solve this derivative is a quotient rule. Let's do this one together, okay? Bottom. D top. Derivative of 1 is 0. He's a constant. Minus top. D bottom. Bottom D top minus top D bottom. Huh. All over. Did I do the quotient rule properly? Yeah. But what's 0 times anything?
0.
So I have 0 minus 1 times anything is itself. All over sine squared of x. Well, 0 times, hold on. Isn't 0 minus cosine the same thing as just negative cosine?
Yes.
Well, that's not pretty. It's right, but it's not pretty. We can make it, ouch, a little bit better if we split up the signs. I know, I'm kind of using T-proof skills from last year. T-proofs, those were fun. Coming back. All I did is say that sine squared is sine times sine and rewrite it a little bit. But isn't it the same thing? Multiply the tops, multiply the bottoms. I didn't change it. I just changed what it looked like. Who's cosine over sine?
Cotangent.
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 And who's 1 over sine?
Cosecant.
Cosecant. Huh, guess what? That's a thing. You guys, ready, set, go. Derivative of secant. Maybe, using what you saw about tangent and cotangent, maybe you can apply that to secant and cosecant. They are going to be similar. You can make a guess as to what you think the answer is, but then I want you to do quotient rule to 1 over cosine to show that it's right. But maybe, just maybe, you can tell. Because you think the pattern, there is a pattern, and you're right. Let's do quotient rule, make sure we're right. Make sure it works. Were you guys super spiffy and even made it look pretty? Bottom d top minus top d bottom all over bottom squared. 0 times anything is 0. Minus a negative sign is plus sign. 0 plus sign is just sign. How did you rewrite it? Did you split up that cosine squared? Said split it up and I started to write it. Oh my goodness, who's sine over cosine?
Tangent.
Tangent. And who's 1 over cosine?
Secant.
Interesting, and it ended up being positive, yeah? Hey, I guess that's a thing. Do you notice that the C one has a negative again? C, it's a negative. For cosecant, I have a cotangent and a cosecant, and for secant, I have a tangent and a secant. I think there's a pattern yet again. Now, once again, could we do it the long way every single time? Sure, I suppose, but our time is too precious for that. Oh, we'll come back to that in a second. Oh my goodness, where? Oh, I skipped it, thank you. I was like, where are my formulas? There they are. Oh. Right. And then memorize. Wait, memorize? What do we do to memorize stuff? We put them in our forever cards. Nice. So yes, indeed, this is going to be a forever. However, I think there's something kind of important that we didn't write down yet from this section. And what was it? I'm going to make this forever number 11, but that means there was a forever number 10, but we didn't mark a forever number 10. Guess what forever number 10 is going to be?
Is it the quotient and the
Product rule, quotient rule, all in one card. Product rule, quotient rule, all in one card. It's pretty important, yeah? I think we need to memorize that one. First d second plus second d first. Bottom d top minus top d bottom all over bottom squared. That'll be forever number 10. So if you want on this slide, when you go to find forever number 11, remember forever number 10, I want it to be, and they were on different slides, which made it hard to say earlier, hard for me to box and make it all nice and pretty. I want the product rule and the quotient rule all in one card. Come on, it's easier than the 16, 20, 30 basic graphs or whatever we had. Wasn't that many. 18. Forever number 10 is the product and quotient rules. Forever number 11, more or the rest of the trig derivatives. Do we got it?
No.
Do we almost have it? Is there a pattern between the ones with tangents in their name And the ones with secants in their name. Yes. We just have to get it down. And let me give you a quick heads up. Every year, there are kids, even at the end of the year, that still don't have these solid. Let me tell you one more thing. Remember derivatives answer one big question of calculus? The tangent line problem? Do you remember what answers the second huge problem? The area problem?
I'll show you underneath the curve.
Under the curve. Did we talk about it? The squiggly essy thing in your calculator? It's called an, starts with an I. Integral. Guess what? Integrals are kind of like derivatives backwards. What? We look at secant squared and we're gonna have to know it comes from tangent. So to be able to do this backwards, what have we better really know? How to do it forwards. Otherwise, when you come to doing it backwards, it'll be like, what? Okay. Keep going.
Yeah, that's.
Oh, this looks fun. Ah, there's signs. Let's skip it. We don't have time. We have to look at 2b, which is a mess, right?
Yeah.
Ooh, do this one. Ready, set, go. Do you see it? Now do you see it? Now do you see it? There we go. Find f prime. That's your direction. That's your objective. That's your goal. Ready, set, you have the rules. Go. Ready, set, you have the rules. Go. Just the way it's written. And some of you, my T-proofers, are like, wait, but I can change that to be and then that to be and then maybe I can simplify this to be. Let's just say all the multiple choice answers don't have sines and cosines, but they do have secants and tangents. Leave it the way it is and use the rules that we just wrote down.
Got a top and I got a bottom.
Gotta use my rule. Can I start now? Yes. Silly smart boy.
Can't you say that? Never mind.
It has to be tangent square x. This way has to be tangent square x.
Oh, they all have secants. Oh.
The bottom secant squared x.
Secant squared x.
Isn't it bottom? Wait.
This is how I don't know this.
We're matching up okay? Did I do anything silly or ridiculous? I did bottom d top, derivative secant, secant tangent minus top d bottom, secant times 0 plus secant squared, all over bottom squared. I distributed a tangent times a tangent is a tangent squared. I combined secant times secant is secant cubed. All over plus 1, all over 1 plus tangent of x quantity squared. When I pull out a secant, I have a tan squared minus a secant squared, which actually ends up being a -1. Ugh, so close. I could almost reduce, but I can't. The signs are different. Some of you are like, can't you multiply things out? Yeah, we could, but it wouldn't help a lot. We could technically get 1 plus 2 tangent of x plus tangent squared, and 1 plus tangent squared is secant squared, so it'd be secant squared plus 2 tangent of x, but I'm not exactly sure that's way prettier. Just remember, there are many different ways of writing the same exact answer. Maybe not many, but at least a few. We just have to keep our eyes open and be aware. Just have to keep our eyes open and be aware. We might get something like this and look at the multiple choice, and they might have something close but change a sign or something, and we're like, no, we're right, that's wrong. Then they might have some that look a lot simpler, and we're like, ugh, what did they do? Is there a property I can use? And then we go ahead and try to use it if we can. Tricky, 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 tricky. Tricky, 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 tricky. You guys ready?
Yeah.
So I just put a quick note in, when solving for derivatives of trig functions, and we have all this trig being put together, just watch out that every now and then, in order to simplify, to make it look like the back of the book, or to make it look like a multiple choice answer, to make it match, they might use an old trig property every now and then. But I'll be here to try to help you through and be able to see it. Okay, there's one more big idea. There's one more big idea. Oh my goodness, it looks so hard and ridiculous and awful and horrible and pause. Don't write this down, pencils down. Don't write this down. Basically, period 1 barely got this far. They definitely didn't have time to write it down. I would like you guys to finish it in your notes tonight, but I'll probably also, if you tend to get in here a little bit early, I'll have it on the screen tomorrow for you to print to get down. Here's the idea. There's one more big thing, it's kind of small. That's a big idea in our section. Basically, the idea that we can find higher order derivatives. What? It's basically saying all this stuff we've been doing is called a first derivative?
So,
What do you mean first derivative? We've just been calling it the derivative. And that's true, it is the derivative, but the first derivative. Which means, guess what? We can double prime y. We can find f double prime of x, and then there's different Leibniz notations down there. But what does it mean to find a first derivative and then find a second derivative? Go again. What? Derive it and find f prime and then derive again. And if you needed to find a third derivative, you can derive again. As long as, what does it say up at the notes above? As long as you can keep going. Maybe there are some functions where you can't keep going. And as long as you have non-trivial derivatives. We'll talk tomorrow about what that whole non-trivial thing is and when it is trivial, and see if you discover it in your homework. But for right now, real quick, you don't even need to write it down, it'll be on the notes online, you can check it out. Remember how we were talking about position and velocity? Position is where it is, right? Velocity is how fast it's going, and velocity, positive, negative, in what direction. What's acceleration stand for? How fast or how much the speed or the velocity is changing. Wait, it's like a rate of the rate? A rate of the rate. A rate of a rate is a double derivative. And technically we're not using x's because we're thinking that it's going to have time in there, so we're doing ddt instead. But a rate of a rate or a derivative of a derivative is what we call a second derivative. So we can say that acceleration is the velocity's derivative, or another way of saying it is the position's second derivative. Anyway, we'll see how homework goes. Nice thing is, most of homework is product rule, quotient rule. Let's throw in a little bit of weird trig, and then at the very end, maybe a couple second derivatives as well. And maybe even a question that asks about acceleration, and you have to find the second derivative of position to do it. That's where we're going tonight, but for right now, hey, we have to go back to section 2.2b, and we have about 10 minutes to do so. So, get into your spirals, get into your homework number 9. Right? Homework number 9? $89 was the first one, right? What was the first even after 89? 82. Hold on. How many of you guys for number 89 got a little bit stuck and went to Calc Chat and were like, what are they doing? Okay. In number 92, and similar to number 89, I think they were in the same section, there were two big ideas they were asking you. They wanted you to find an average rate over a time interval, and they gave you that time interval, 0 to pi over 6. Oops, that's not a parenthesis. They wanted you to find an average, which will be one answer, over a time interval. You have to use both in order to get the answer. And then they wanted you to find an instantaneous, but an instantaneous at the 2 points of the interval, which means you should have 2 different answers. Three answers total. But what were they doing? I think technically the first question they asked you was to find the average rate of change. Didn't we talk about this formula in our notes? F of b minus f of a all over b minus a. How do you solve this formula? Take b, plug him into the b spot of the formula. Take a, plug him into the a spot. Take b, plug him into the b spot. Take a, plug him into the a spot. F of pi over 6 minus f of 0 all over pi over 6 minus 0. But how do you keep going? What does f of mean? It's a function value or a y value at an x. How do you know who he is? Plug him in, plug him in. So an in-between step right here. Remember, CalcAB always takes jumps because they're smart. I understand. The grad students know what they're doing some of the time. But how would I have done an in-between step? I would have plugged in the sign for f of pi over 6, and I would have plugged in the sign for f of 0. And what is sine of pi over 6? 1/2. And what is sine of 0? 0. And then they simplified. Now hold on. Wait a minute. 1/2 and pi over 6. We've seen that somewhere in this solution. Sorry, 1/2 and 0. That's what they did up here with the weird pointy things. They said, oh, I know the x, let me plug in and find the y. They found the 0. Oh, I know the x, let me plug in and find the y. Oh, they separated the steps. And they did this plug and chuggy thing way up here at the beginning. But whatever, I think that's weird, I think that's complicated. I think that's different. Doesn't mean it's wrong, it's okay. But that confused some of you guys. To find average, we need to plug in pi over 6 to the original. Plug in 0 to the original. Get y2 minus y1 over x2 minus x1 and simplify it. Ends up being 3 over pi. Watch out for that complex fraction. For instantaneous, plug it in, what? Each one into, 2 pi. Are you guys laughing at that? What was the answer? Pi over 6. Plug them in, where? To the derivative. Derivative of sine is cosine. Plug it in, solve, done. Compare. I don't know, look at them and say, they're different, and then you compared. For number 89, it was like, they're the same. Okay, whatever, you compared. Do we get the difference between average and instantaneous? average, we gotta use the formula. Plugging in where? Derivative or original?
Derivative. No, original.
Original. You're making the rate yourself. You're doing a change in distance over change in time. For instantaneous, you're using the derivative, who is measured in distance over time itself already. Kind of. Couple more seconds. You guys technically just need to write down answers, but I know that some of you got confused by CalcChat. Use it wisely. Go to our notes first. Go to CalcChat last. What's our next even?
96.
There it is.
Yeah, I'm fine.
How on earth they had to plug in stuff. You had to plug in stuff because they gave you this general formula first. That's funny. General formula. I wish I had covered that for you. Oh wait, I did. Remember the free fall clues page? And remember how I pointed to this one and said, hey, who is V sub naught? Your initial or beginning who? Velocity. And if something is dropped, what's your initial velocity? Make V sub naught or V sub 0. If it's dropped, make it 0. If it's thrown or propelled or shot, make it whatever speed, or I should say whatever velocity it's thrown or propelled or shot at. This one had initial velocity, and why is it negative? Because it was going down. And what was this little s sub naught, or s sub 0? S sub naught is like the physics way of saying it. What's s sub 0? Initial height. Oh, plus 220. It must have started up somewhere. It did. I think it was on top of a building, yeah? So you had to pull out from the words what the initial velocity was and put it in the right spot, and what the initial height was and put it in the right spot. But then they just said, hey, find the velocity. Oh, just take the, who is velocity? Use s prime. Just find the derivative. Power rule. Find the velocity at 3. Oh, no big deal. What are you supposed to do? Plug in 3 and label it with the proper units of feet per second. And then the last one, oh, he was kind of tricky. But what were you doing to finish the problem? They asked, what was the velocity after 108 feet? They asked, what was the velocity, which is what the final answer is down here. What was the velocity after 108 feet? What do you mean after 108 feet? After it's fallen 108 feet. Question, if it's fallen 108 and there's 220 total, what's its position off the ground? You have to subtract. 220 minus 108, it's 112 off the ground. And I take my position function, which I don't think they do a great job of showing you. Take your position, that's the wrong marker, but that will do the trick. Why am I plugging it in here? This is feet. And who's the only one that stands for feet? Position. Velocity is feet per second. That doesn't match. And then how do we solve? We subtract the 112. We end up with, okay, 108. Then you could go the factoring route and do the by hand mathematical route, or you could do the, hey, I'm going to my graphing calculator and I'm going to try to graph and find the 0, the x-intercept for a positive time. Whether you solved this away or whether you went to your graph for the only positive time, and that's usually the only applicable time, is 2. Once I have time, they said, what was the velocity? Plug it in, done. Nice thing is, this is being recorded on the video, so if I'm going too fast, watch it tonight, slow me down, and see if you can follow the steps. What's our next even? 98. He's a little baby one. But you still had to plug in stuff. And what did they plug in? They plugged in, it was dropped. So since it was dropped, hold on, since it was dropped, what was my initial velocity? 0. Hence, that went away. Then they said, time equals 5.6. And it's on the ground, which means s is equal to 0. All you had to do was plug and chug. 5.6, solve for s sub naught, and you get 153.7. If there are any evens that we didn't go over today, we'll go over them tomorrow. Work on 2, 3 tonight, and I'll see you later. Bye, guys. I won't be here super long after school.
You have a question, James?
Oh, no, you're.
I mean, whenever,
This doesn't matter with respect to that. That's the important part. The negative, a huge number down here.
I'll tell you what he said out of nowhere, but and he hasn't texted me since he like probably found it.